Hello everyone, this is going to be a quick video tutorial on how to overlay and merge your microscope images. The program that we will be using is called ImageJ, otherwise known as Fiji. It is cross-platform, so download and install the one that is compatible with your operating system. The download link was provided in the email that I sent out yesterday and is also shown here. Feel free to follow along with this video with the PDF instructions that is uploaded onto GouchoSpace. And with that, let us begin. Also on GouchoSpace, there is a folder called micrometer scale bars. You will need this later for putting the scale bars on every single image that you develop on ImageJ. And essentially, every single microscope that the class was using is different, and with that, they have different objective lenses. So when the computer acquires the image, it stores the pixel data in pixel units, and what we want in our images so that we can establish a scale bar that is in microns, we need a conversion method. So these images were taken by the microscope by their individual models, and essentially we will be using that as a reference for the conversion from units as pixels to units as microns. So that I will include with the email that I send out later the kind of layout of the microscope room, so that in case you forget and what model to use essentially for the scale bars. So with that, you would also need your images. So with the email that I sent out yesterday, it outlines the instructions for the results section. So I would suggest organizing your image files, selecting the ones that you're going to pick for your figures, and having an organized system based on the legend that you and your partner have agreed upon. And it is okay if your images are in the format of JPEG or TIFF. I noticed some groups with the TIFF files, they are enclosed in these folders, and the TIFF file themselves have this default file name that the acquisition software gave. So I would, also organize that, rename them accordingly to your legend, and so those are basically the necessary components for you to merge your images and overlay them. So what you need is your DAPI image and your JPEG image, and I am using an example that my group has taken last year, of an example of a mitotic cell. So the PDF instructions say to use the bioimporter from the ImageJ program, but you can simply highlight, select both the DAPI channel and the GFP channel, and drag and drop onto the ImageJ program, and they will show up. And in this case, 29 would represent my DAPI channel, and 30 will represent my GFP channel. And I would like to point out that these units are in pixels. It is an 8-bit image, and it does show, it does indicate the size of the file. So the first thing what we're going to do is to merge and pseudocolor these two channels to create a composite overlay image. So to do that, click on Image on the ImageJ menu, and then click on Color, and then click on Merge Channels. And with that, a window will pop up, and you will have to assign the corresponding channels to the one color that you want to pseudo-color. And for blue, my DAPI channel, number 29, and for green, I'm going to pseudo-color it green, my GFP channel. And then be sure to have the Create Composite box checked. You can have the Keep Source Images box checked, but that is only if you would like to keep the grayscale images. For your final lab write-up, since you will be printing in color, you have a choice to, have your DAPI channel and your GFP channel in color. So that's what I'm going to do, and so I'm going to leave that unchecked. Essentially later, you can have a scale bar in all of these images as well if you do keep source images and keep these windows open. So I'm going to press OK, and now I have my merged overlay of my image, and some of your images will be dark. Your DAPI channel might be really dark or really bright, and your GFP channel might be kind of dim. So in order to do that, we will have to adjust the brightness or the contrast of the composite image. To do that, we will go to Image, Adjust, and Brightness/Contrast. The shortcut would be Control-Shift-C, and this window will open. The PDF instructions do say to adjust the type to RGB color. I would suggest doing that after we input our scale bars, just to make it all simple. So once you have this and this window open, you can make your adjustments on to the corresponding channel. Now, notice that these texts are highlighted in green, and this slider is in this position. So any adjustments made right now will be on the green GFP channel. And if I want to make any adjustments on the DAPI channel, I would have to slide the slider. And notice that the text and the kind of the outline of the window is blue. So just bear that in mind. And so this will take time. Essentially, you want to aim for the best representative image. So by adjusting the brightness and the contrast, making it look physiological, right? So this will take some time. So I will actually pause the video here and make those adjustments, making sure everything is set correctly, and making it look physiological representative of what a cell should look like. So I will be right back. Alright, oops, I am back. So hopefully you've taken your time making the right adjustments. I made my adjustments to make it representative. And so once you have made those adjustments, you can close this window for adjusting the brightness and contrast. And what our next step would be is to add a scale bar. So in order to do that, we need to convert the pixels into microns. So the purpose of these scale bars is to do just that. Last year we used the Olympus BX60 microscope, and this image was taken on the 100x magnification. So I will use this as my reference, and you can simply drag and drop it into the ImageJ panel, and your image should open. I'm going to move this here and this here. So what you'll do is use the line tool to draw a line from the first visible tick of this ruler to the last visible tick of this ruler, which will be right here. So you want to be drawing a straight line, essentially, following along with the orientation of the imaged ruler. And I believe this will be straight. And this will be our reference. Essentially, every single tick, the distance between one tick from the other is 10 microns, or micrometer, 10 microns. So I count that there are 16 ticks. So with it being 10 microns and 16 ticks, I total have 160 microns that this line has just drew. So we're going to analyze this. So by clicking analyze, and we're going to set the scale. And once we click this, a window will open up, and this signifies the distance in pixels. And what we know right now, our known distance, is it's 160 microns. And so that this is our conversion, so that the ImageJ will know that our conversion factor, essentially. So be sure to have this this box checked global. So once we press OK, it will send this conversion factor to all the opened images currently on ImageJ. So we're going to press OK, and notice that the units will change. Pixels will change to microns for plural. So now that it has changed, we're going to go back to our composite photo and add the scale bar. So to add a scale bar, we're going to click Analyze, we're going to go to Tools, and we're going to click on Scale Bar. Now the scale bar will show up here. You can adjust accordingly to the objective lens, objective magnification that was used. I would just say be consistent among your panels. So for all my 100x magnifications, I will use 50 microns. You can, change your font size, the height in pixels of the scale bar, but I would just, remain consistent among all your images. And one important thing to have checked is label all slices, because later on, if you want to have colored images of your GFP and DAPI channels, you also want this scale bar there. So it just does two things at once. Bolded text and overlay should be checked as well. And the location we want it at the lower right of the image. So we're going to press OK, and this image is, this composite photo is essentially finished. So we're going to save this image, this composite image, as a JPEG. In order to do that, now what we'll do is go to Image, and we're going to change the type to RGB color. Now this will open up another window of the same image, essentially. So now that we have a window that has composite RGB, and this one is still the 8-bit image that we have been using to do our modifications. I will have this window still open, and we'll have this RGB image composite image highlighted, and click on File, and then we're going to click on Save As, and go to JPEG. And this, what we'll do is we're going to save it as a JPEG. So name it accordingly for according to your system of organization. I'm just going to name it as Composite. Composite, and I'm going to save it. So this will save as the RGB file and RGB formatted file, so that it will be for your final lab write-up, it will be in RGB format for printing purposes. So after finishing that, we can close this out now. Essentially, you have your composite file saved. Now what we're going to do is have our GFP file and our DAPI file also obtained from this composite file. So in order to do that, we're going to click on image, and we're going to click on color, and then go to the channels tool. The shortcut is also Control-Shift-Z. So at this point, a window will open up, and here is our composite. You have three options. You can go to grayscale. You can have them print as grayscale, or you can have them as color. So for me, I'm going to select color, and now you'll see that it is back into this format where there's a slider here. So this is my DAPI channel, and this is my GFP channel. Now as being split, and we're actually going to split this window into two windows by doing this. So we're going to click on more, and then we're going to click on split channels. Once you do that, now you'll have two windows open, and this is essentially doing two things at once, or having two things accomplished at once, so that there's a scale bar on every single image file now that you need for one single panel. So we're going to do the same to each of these. For this highlighted window, you're going to click on image, click on type, and we're going to do RGB color. So essentially it's going to be now RGB, and you're going to save as the right file name according to your system. And I'm going to save that as PDF. I'm going to save that as DAPI. And as a file name, you can close this now. And then I'm going to do my conversion here to RGB. And then I'm going to also save as JPEG. And then this will be GFP. Awesome. So now to see the final result, I saved it in source. So now our composite image is now ready to be placed into our final lab write-up, as well as DAPI and GFP. So that is how you overlay and merge these microscope images. So you will have to do this to every image that you have selected for the figures. And for that one figure, that for figure 2, that just has the DAPI channel only, you can just have that as a grayscale file. Just it's important to have the scale bar on it. So whenever you do overlay your other image files, be sure to have this this menu still open, the ImageJ menu still open, because it does retain the scale that you have set. So any scale that was like just calibrated will also apply to any image that was opened with this program. So just to keep that in mind. Other than that, if you have any questions, please email me. And I hope this video was helpful. Yeah, thank you.